Yes.
Okay, we are going to start our second presentation, but before we start, we want to remind you that there is upcoming conference, Python PL, in September, so we invite you to visit their website and attend that conference. We support them as they are like the main Python conference in Poland, and yeah, that's all about this announcement. So now let's have a presentation from Przemysław about OpenTelemetry. Let's give him a big round of applause.
Thank you very much. Hi everyone, I'm Przemek. I am a Python developer and I work at Sailor Commerce where we develop like an open source e-commerce platform called Sailor. If you are interested, I invite you to our webpage and also a GitHub page. I am also very honored to be able to present here at PyWaw. I remember attending one of my first PyWaw events many years ago when I was still a student and I was at the beginning of my journey as a developer. And today I would like to share with you some of my experience with implementing telemetry as a way to extend observability of quite a big Python project which Sailor is. So what is observability? Basically it's an ability to understand the internal state of our software system. We can use it to monitor system performance and its behavior. We can troubleshoot issues and identify some bottlenecks. We can also use it to optimize our system and to improve reliability. And we can basically describe 3 levels of observability, where the basic one is a good old simple status page, which can tell us if something is broken or not. The higher level those are all kinds of telemetry dashboards or some telemetry data providers which can not only tell us if something is broken or not, but we can also use it to monitor some systems and to check its state even if everything is going fine. And at the highest level, there are like fully fledged observability systems which enable us to collect and manage telemetry signals coming from like bigger software systems, typically consisting of many services, complex one and distributed. And OpenTelemetry, in short, OTEL, is an open observability framework and toolkit which is trying to tackle this problem. It is becoming de facto standard in the industry. It is focusing on generating, exporting and collecting telemetry data divided in 3 types of signals: metrics, logs and traces. It also gives us the OpenTelemetry protocol, or TLP, which defines how telemetry signals should be transmitted and encoded. And intentionally, all the stuff related to storage and visualizations is left for other tools, which are by OTEL called telemetry backends. And we can choose from majority of different ones like open source Grafana or Prometheus, and also tools like Datadog or New Relic. But my plan for this presentation is to show you the powers and features of OpenTelemetry using like a concrete example. So let's imagine like a simple e-commerce setup of a bunch of services which are like integrated around Sailor. We have some kind of a storefront. It could be like a web browser application or some mobile application which is communicating with Sailor using GraphQL API and based on HTTP. Then in the center we have Sailor, which is headless, composable e-commerce platform, but from technical perspective, it is quite big Django web application, and the composability is realized by enabling to trigger some specialized events and to communicate with external services between and we call so this is the way for Sailor to delegate some stuff to outside services. We call those outside services apps, and those apps can be used, for example, to integrate with some payment gateways, to implement some shipping methods, or provide a way to send transactional emails. And having such test setup prepared, let's see what OpenTelemetry can offer us in case of observability. So we'll begin with the concept of traces. Traces can show us the full picture, of, like the full way the request which is entering our system will travel. And here is like a print screen from a popular application called Jaeger, and we can see a list of traces coming from the Sailor service. Inside, like looking into one of such traces, we can see a flame graph with different composited of different spans, which are like a building blocks for a trace. Those spans are related to each other, and also every span is like uniquely identified by its span ID, and all of them are like assigned to the same trace, also identified by a unique trace ID. We can and like every of these spans represent like an unit of work. So, for example, the first one is represents the Sailor processing the HTTP request. Then we have a span representing the GraphQL operation, and at the last one is a request to the external service, and in this particular example it is a request to the shipping app. We can look inside every span, and we can extend the information inside the spans using a thing called attributes. Those are like this is like a key value storage, and typically we can assign information as for example a status code or a response body size for HTTP spans, and we can also have, let's say, operation name and operation type for GraphQL spans. But also a very important part is that for every span we can exactly see when it started, when it ended, and how long it lasted. And this information can be very helpful for us, for example, to find some bottlenecks. And in this particular example, we can see that the span representing the request to the external service is taking the majority of time used to prepare a request. So how can we make our Python code start to emitting such spans? It can be done using OpenTelemetry's API and SDK libraries. We can start by installing required dependencies. Then we need to import some modules, declare a tracer, and now we can start to generate spans. The easiest, in my opinion, way for doing that is using quite convenient context manager, start as current span. And basically we can wrap whatever part of code we want to with this context manager, and it will be basically wrapped with the span. While starting a span, we can assign it a name, kind, a set of attributes. Attributes can be also assigned later. As you can see here, we are assigning an attribute with a response status code, and we need to do it after the response is generated. And also, you can notice that I am using predefined set of attributes names. And this is also a recommended approach, recommended by OpenTelemetry, and they have whole documents of with definitions and descriptions of many different attribute names we can use. And basically, the recommended approach is to, whenever we can, we should use the predefined attributes, because it will be very beneficial for us later when we would like to correlate signals from different sources. Another simple example, here we are also creating some span. This one is for this one is wrapping GraphQL operations. But what I would like to show you is that basically this function is previously invoked inside the span we created previously, and that's the way how we can create nested spans. So basically, in such a scenario, the GraphQL span will be automatically nested inside our HTTP span, and there will be a parent-child relation created between them automatically. And that's basically all in case of basics of instrumenting our code with spans. There is also a different approach. It is called auto or zero code instrumentation. And OpenTelemetry is preparing a lot of integrations with many popular existing Python libraries like FastAPI, Django, requests, PsychoPG. And by simply installing one of such integrations and then activating it, the library is automatically patched to generate telemetry signals. And so this is, for example, a way to instrument our application quite easily without the need of changes in our code base. So right now we have all of our services are instrumented. They are generating some telemetry signals, and they are ready to export them. But where? And again, the OpenTelemetry comes to the rescue, and they provide a thing called hotel collector. It's an application written in Go, and it is quite well optimized to receive process and export telemetry signals. And by deploying such throttle collector right next to our services, we can very easily offload all the telemetry signals directly to the collector, and collector can do some additional processing like batching or aggregating. And it can also, for example, handle stuff like encryption. It can even do stuff like filtering some sensitive data before sending it to our telemetry backend. And hotel collector is also very easily configurable, and we can suit it to our needs. On the right side, you can see like a super simple basic configuration in form of YAML file. But what I would like to show you is that the main part we are configuring is a declaration, like for every type of telemetry signals, traces, metrics, and logs, we declare a pipeline consisting of a bunch of receivers which can gather data from multiple sources. Then we have processors, and the OpenTelemetry is providing us with a huge library of different processors, which can we can use them to edit, group, batch, aggregate our telemetry signals. So we can and we can build like a whole pipeline of these processors, and at the end we can define where and how signals should be exported. So as you can see, we have quite a lot of options to customize the OpenTelemetry collector. Okay, great. So at this stage, our system is generating, collecting, and sending telemetry signals, but we are missing last crucial piece, and because our goal is to now to correlate all of these signals together, and we can achieve that using the mechanism called context propagation. Context propagation is a form of is a way of propagating the context between the boundaries of individual service. It is defined, and context is basically just an object containing the crucial information like trace ID, span ID. And here in this example, we start with a storefront which creates a new span, a new trace ID, but then sends a request to Sailor. But while doing that, it also serializes its context and attach it to the request. And thanks to that, on the Sailor side, we can read and deserialize this context and use it to create our own telemetry signals and spans. And this the context propagation is also happening later in all the communication inside our system. And the benefits of context propagation can be seen here, because here we can see so basically we can see the spans coming from all the services which were taking part in processing the request. We start with a storefront, go through Sailor, and then end up in a shipping app. Also, many of these telemetry backends can use this context information to, for example, automatically build us a service map of our system, and usually it is also extended with some additional health and health information or some other statistics. Okay, but at this stage, one problem. So basically, there is no possibility for us to generate trace for every processing that will be that will generate quite huge costs for hard to conduct. So what we can do with this? So the proposed approach is to instead of sending all of instead of collecting all of our traces and spans, is to choose like a statistically representative small sample of our traces and use them, collect them and use them to build like a actual representation of whole of our traffic. And OpenTelemetry comes with many different sampling strategies. Basic one being just like selecting some small percentage of all traces, like 1 or 5%, something like that. But there is also a possibility to define custom strategies, like let's say we can like define a strategy to have a higher level of sampling of attributes, but because of we are sampling our traces, we now can't use them as a source of information to calculate like a statistical represent to use it to create because we are not getting all of the information. And the second, because we are not getting all of the information. And the second type of telemetry signals called metric, this gap, because metrics give us the possibility to measure almost everything and all also all the data from the all the data from the measurements are used there is no sampling, and everything is used to everything is collected. So we have like a very precise representation, and there are OpenTelemetry comes with many types of metrics, but like the three most populars are counter to measure some values which is like constantly increasing, like it is perfect for counting like total request processed, amount of errors, total bytes processed. Second type of metric is called gauge, and which can go up and down, like active connections, some queue length, or CPU utilization. And at the end we have histograms, and those are histograms are grouping all the measurements into predefined buckets, and metrics of type histogram can be like perfectly used for measuring request durations, response sizes, basically any value where we want to understand the distribution of the measurements. So where we do not only need, so the histogram metric can tell us not only like an average response time, check how many requests were like quicker than 20 milliseconds, how many were quicker than 50 milliseconds, and how many were much longer than 2 seconds. Okay, and how to instrument our code to create metrics? We need to start with metrics definition. While defining a metric, we need to choose a type of a metric, provide like a unique name for such metric, add a unit and description. And in case of histogram type metrics, we can also provide a list of boundaries of the buckets we will be gathering our measurements into. And here you can see how we can create measurements. It's very, very easy. We can call the function on, call the method on our one of our metrics, and the first one we just increment the counter with a value of 1, and we can add some attributes. In this example, the attribute we are adding is an error type, and thanks to that we can, for example, use this metric to calculate the error rate. Also, here's an example of recording the duration for duration metric. And here you can see metrics in action. Metrics, after gathering all the metrics data, we can use them to build dashboards, which can help us to visualize our system. We can over some time, but like a killer feature of metrics is that we can, using them, we can set up automatic monitoring and alerting. So basically, we can, for example, put a monitor that will alert us whenever the error rate will be like higher than some provided value as like 1% or something like that. It is also very, very useful for capacity planning. So, for example, we can use all of this information to optimize and better infrastructure. And last but not least, logs. So, OpenTelemetry is graded in the standard way of logging in Python. We can use logs like typically for recording. They are usually in human readable format. They can give us much more context, for example, with some detailed error messages. We can log business logic, etc. And OpenTelemetry integrates with standard Python API for logging, but also is extending all the logs with an information with the context. So for example, trace and span ID. And thanks to that, as you can see in this print screen, whenever we, for example, debug something and we investigate some problem and we find some trace. So whenever it is possible, the system will show us all the log events related to the same request. So we can, so everything is correlated and we can see all the information all at once. And with logs, this is it, because we handle all the types of signals which OTel can operate with. And that's everything for me, from me. It was a pleasure. Thank you so much. And maybe some questions. I see first question.
Or maybe you could, maybe you should just repeat the question. So my question is, because you provided information about the fact that you're generating data to the OpenTelemetry agents, and there was a port defined. So I assume this should be located as close to the application as possible. That's one thing. And what's the protocol used in it, and what the because, for example, is it unblocking for the processing of the application?
Okay, thank you for the question. So we can deploy OTel collectors in like basically two types of deployments. One is like an agent type. So as you said, as close as possible to our other of our pods, for example, on the same node. That's one approach, but OTel collectors can also work in something called gateway deployment setup, and then so basically we do not need to have hotel collectors like on every node in our cluster. They can also quite well function in this more distributed setup. And to answer your question, there are many different protocols handled by hotel collectors and OpenTelemetry, but the main one is this OTLP, and it can use HTTP as a transport protocol or gRPC. But to answer if the process of sending telemetry signals is blocking, yes, of course, there is some, especially in Python application, there is some kind of overhead. But the implementation in OpenTelemetry SDK is the default implementation is starting like a separate thread, which is basically all the telemetry signals produced are grouped in some kind of in memory, and once every couple of seconds there is like a separate thread worker which is handling this the stuff of sending the signals to collectors. So there is some kind of overhead, but if we can, for example, see that we are producing too many telemetry signals and the overhead is too high, we can try to manipulate those values. We can, for example, put lower sampling, and that should result in less telemetry signals produced and the process going much more smoothly. I hope I answered your question. Are there any more questions?
I see there were like processing pipeline, right?
Yeah, yeah.
And I understand you can do something similar with Grafana and like other backends.
Mm-hmm.
Is there any advantage of doing that using OpenTelemetry, or is it the same, or
Okay.
what is the point of doing that?
Yeah. Thank you for the question. It's a great question. So basically, what I'm showing here is that we can create a processing pipeline inside hotel collector. As benefit is that we can optimize a lot. So, for example, yes, the hotel collector can work just like a super simple proxy and without any processing send, for example, our metric data points directly to the telemetry backend of the telemetry backend, and that's usually comes with a cost. If you are hosting your telemetry backend yourself, you will pay for all the traffic and stuff like that. If you are using some software as a service solutions or stuff like that, you will just pay in terms of, for example, more data being processed on their part, and they will. So basically, that's the main point. And for example, we can use OpenTelemetry collector to do like a pre-aggregation, for example, of our metric. Let's say that we have like hundreds of pods selling their telemetry data into our telemetry hotel collector, and then we can set up the pipeline in such a way that all of the from one period of time, all the data metric data points will be aggregated, and at the end, our collector will only export like just one data point, representing like a huge chunk of our whole infrastructure. So that's the main reason. Any more questions?
I have a question about sampling.
Sampling. Mm-hmm.
Yeah, because our like main service and some
Yep.
microservices.
Mhm.
So how sampling does work? Does it work like that our main application sends to other applications that okay you have to
Mhm.
log everything, or this is like if we are or sometimes we can miss some.
Another great question. I didn't want to go into all the details because of the lack of time during the presentation, but that's a quite complicated problem, but it is also tackled by OpenTelemetry. So basically, the main idea for that is when you are running this strategy, which will decide if you should sample or not, and that is also quite a deep topic and can be done in many different. But let's simplify it. And so, if we are doing like head sampling, so we are making this decision at the beginning, we can include the sampling decision inside the context. So basically, when at the beginning we will decide to sample this trace, whole trace will be sampled, and the context will be propagated through the whole stack, and all the spans in between will be sampled, and we will see everything. But this is quite complicated problem. It can be quite tricky, and so it's not very easy, but there is many methods to approach this topic.
Thank you.
Hi. So I've used some of these platforms for tracing or observability, but I haven't actually implemented one. So is there something you might lose using an alternative solution to OpenTelemetry as a protocol? Say if Datadog or New Relic do they have any proprietary solutions that you might lose something by only going for the open source stuff?
Wow, all the questions are great. So we have another one. Basically, to answer, of course, there are the landscape is changing quite dynamically. And for example, Datadog, which is like an industry leader, and they implemented basically all of these functionalities previously, but they were a little bit different and they were proprietary. Basically, yes, there are some differences. For example, if you are using today, if you are using Datadog with OpenTelemetry SDK, Datadog is like quite well integrated in OpenTelemetry, and you can achieve most of the stuff. But for example, for sure, you will not have database monitoring. That's one of their services which they are offering with when you are using their implementation of tracing, for example. But this landscape is quite dynamically changing because OpenTelemetry is like growing in power, and and it is becoming de facto standard, and more telemetry backends start to fully support it. So so right now it is a trade-off, but there is less and less stuff you can't achieve when you are using OpenTelemetry. Any more questions?
So my question is about the purpose, because I've been using this. How would you compare this observability with tools like Mixpanel, which also collects some events? Is it that Mixpanel is rather more business focused and this is more performance focused, or would you compare it differently?
I would love to say more, but unfortunately, I don't have idea what a mixed panel is. Sorry, I'm not an expert of the field of observability, but yeah, OpenTelemetry is like one approach for that. It is built on the shoulder of giants of the previous very similar protocols like OpenTracing and stuff like that. For our needs, it fits very well, because we are developing a e-commerce platform which is directly market to developers. And we are trying to provide more observability for their perspective. But I totally can imagine that there exists a lot of different approaches to observability from different perspectives, maybe more business one, and observability is only one of them. Any more questions?
Performance is its own separate thing, and it's not standardized in OpenTelemetry.
I'm not sure if I'm getting a question.
No, it's not a question, it's a statement.
It's a statement
Okay.
to the mixed panel.
Okay.
It's none of those data points is related to performance in any way, other than maybe some requests. Performance like Pyroscope and other things are not yet standardized, but are on its way to be introduced to OpenTelemetry with open or continuous profiling, and you have to use it separately.
Thank you for clarifying that.
Okay, thank you everyone. Thank you, Przemek. That was a great talk, and thanks for attending. This is the end. Please stay with us. We will be here for some time already, but yeah, we need to leave this